Good morning, everybody. So this is a question on Form 5, Chapter 5, Electronics. So if you want to get the PDF of the question, just go to the description below and you will find a link to the PDF of the question. Okay, so let's have a look at this question. So diagram 2 shows a transistor circuit. And this is just a very simple transistor circuit here. And you can see there's the transistor is over here. We have fixed resistors, and then we have this component Q here. We have a light bulb, and we have a battery here. So if you don't know, this is actually a circuit for a automatic circuit, basically. So under certain conditions, you can get the light bulb to light up. For example, like let's say if it's too hot, if it's too cold, depends on what component you have inside lah. But basically, you are trying to make an automated circuit. Okay, so let's have a look at this component Q. Now, component Q, right, you can see there are two arrows pointing on a resistor. This rectangle inside is still a resistor, okay? The arrows represent light, yeah? So for example, a light emitting diode, LED, will look like this. It's basically a diode with lights, okay? Now, this is a light dependent resistor, okay? A light dependent resistor. Normally we call it LDR. Light dependent resistor, okay? So it depends on light to change the resistance. Now, how does it change resistance, right? It's very simple. You just have to remember it always goes opposite to the surrounding. Whether it's light dependent resistor or another one is thermistor. Thermistor means depends on temperature. Both also same, they always go against their surrounding. So if the surrounding has a lot of light, then your resistance will be very little, very low. If the surrounding has very little light, then your resistance will be very high. Do you understand? Okay? So the next question asks you, what happens to the base voltage when the environment gets darker? Okay, so to understand this, right, you actually have to know what this CBE stands for lah. Okay, so the C is the collector leg of the transistor, the B is the base leg, and the E is the emitter leg. Okay, emitter, yeah. Okay, E is emitter. So collector, base, emitter. When they say base voltage, right, they actually mean what is the voltage here at this leg, the B leg. Okay? In other words, what is the voltage across this resistor? So how this automatic circuit work is like this. Between these two resistors, right, they will fight for the voltage of this 6 volts. Whoever got higher resistance will get more voltage. So for example, if let's say this is 20 kilo ohm and this is 10 kilo ohm, then this one will get like 4 volts, this one will get 2 volts. Okay? So whoever got more resistance gets more voltage. Okay? Now, this guy here, the base, always follow whoever is at the bottom. Okay? Whoever is at the bottom, he will always copy him. So if he got low voltage, he also got low voltage. If he got high voltage, then this guy will also get high voltage. Do you understand? Okay, So now, you see, when it gets dark, just like I said, if there is very little light, what happens to the resistance? The resistance will be very high. Opposite opposite of the surrounding okay? So if the resistance is very high, he will get more voltage. Yeah, he will get a bigger share of the voltage. Okay, so we can say the voltage down here will be very high. So that means this base voltage is also very high. Remember, he just copied whoever is at the bottom. Okay, and when the base voltage is very high, the base current is also very high. When the base current is very high, the collector current will also be high and your light turns on. Okay, that's how the automatic circuit works. Okay, so when it's dark, the light turns on. Okay, just in case you are not clear about this, let me give you the opposite example. Okay. The opposite example would be when it is very bright in the morning. When it's very bright, the light-dependent resistor will have low resistance. Okay? Low resistance. Now, if he has lower resistance, he gets lesser voltage. Because this guy is now higher resistance already when you compare the two of them. So, this guy got lower voltage, which means the base voltage copy him low voltage also. So now the base current is also low. If your voltage low, your current is low also. Okay? If the base current low, the collector current will also be low. Then light bulb doesn't turn on. Understand? Okay. Now of course this question never asked until so much lah, but at least you should know how the automatic circuit works. So just now, the voltage increased, the base voltage increased, so I should answer this lah. Increases. Okay, the base voltage increases. Okay, next question. The bulb will light up when the base voltage is 4 volts. Based on the diagram 2, calculate the resistance of Q when the bulb lights up. Okay, so what do we know here? We know that this is 4 volts. Okay, we know that the base voltage is 4 volts, which also means we know that this is 4 volts. Okay? Yeah, we know that this is 4 volts. Now, actually, from here, you can tell this is 2 volts. Why? There's only 6 volts in total only. These 6 volts, remember, is shared between the two. These two are fighting for whoever gets more voltage. So, 4 volts, 2 volts, total 6 volts. Okay? And if you want a shortcut I tell you the shortcut first. Later only we do the proper way. The shortcut is double the voltage means double the resistance. So right now, I can tell that the resistance here is 40,000 ohms. Because this is 20,000 20k means 20,000 So this is 40,000. Okay? Now I'm going to leave it here first so that I can double check my answer later. Okay, now what's the proper way of doing this? You need to understand how do they share the voltage. We call this thing, this concept, right? Potential divider. Because you are dividing the potential difference. So a potential divider works like this. I'm just going to remove the center first so it's not so messy. Imagine I have 6 ringgit. Okay? Imagine I have 6 ringgit, right? I'm trying to split between the people here and the people here. Okay? So right now there are 20 people here, and I'm just going to give a random example. Let's say there's 10 people here. Okay? We're just going to ignore the question first. Let's say there's 10 people here. Right? How do you split 6 ringgit between 20 people and 10 people? So first of all, you're going to divide everybody. You're going to make sure everybody gets the same amount of voltage. So 6 divided by 30. Correct or not? And then you can multiply. After you get the divide ready, you can see, everybody gets, let's say, I think it's 0.2. Okay, if I'm not sure. Sorry if I'm wrong, as I'm not using a calculator now. Okay, so 0.2. Everybody gets 0.2. So then 20 people will get 20 times 0.2 10 people will get 10 times 0.2 Correct or not? So this is how you split the voltage. Okay? The more straightforward way to write this is, after you divide, you straight away multiply. You multiply 20 for the top. Okay? Or you multiply 10 for the bottom one. Okay? Understand? Yeah? So, another way you can say is 6 times 10 out of 30 for the bottom one, and 6 times 20 out of 30. Yeah? These people will get 20 out of 30. These people will get 10 out of 30. Make sense or not? Because 30 is a total So he will get 10 out of the 30 portion. he will get 20 out of the 30 portion. Okay? So this is the way to do potential divider. Okay, now how do we apply this to the question? We can say, oops. Now, we can say that, we know that this is 4 volts, by the way. Again, from just now, we know this is 4 volts. We can say this is an unknown resistor, Q, okay? Then, 6 times, what? 6 times, let's say Q over the total. What is the total? Q plus 20,000. Okay, do you remember just now? Just now it was 10 over 30, right? This is the total. This is how many percent? Now, there's Q percent over the total. Total is 20,000 plus Q. Okay? This will equals to 4. Because they are going to get 4 volts, right? They're going to get 4 volts. So if you move the things around, you can bring this over to become divide. You can bring this over and then expand the brackets. Okay? You will eventually get Q is 40,000 ohms. Okay? Now, if you want to do for the top one, it's also possible. Top is 2 volts. So I can say 6 times, how much is this? 20,000 6 times 20,000 over the total, Q plus 20,000 is equals to 2 volts. Again, bring this here, it becomes divide, and then you can bring this, multiply, expand the brackets, move things around, then you can get Q is also equals to 40,000. Okay? So I suggest you can pause the video and then you can try to do the calculation yourself to make sure you get this correct answer. Okay? If you have any trouble doing it, just let me know in the comments. Yeah? Then I'll try to write down the entire step for you. Okay? So if you learned something, make sure to like and subscribe, and let me know in the comments if you want me to do any exercise from other topics. Okay? See you next time. Bye-bye.